Hi everybody, welcome back. This is Unit 8, Lesson 8, and we're in Section 6 of our Mathematics of Equations notes. The section title, I know it's hard to read, it's called Stoichiometry. And stoichiometry are mathematical calculations in chemistry that you require a reaction or an equation to solve. So in order to introduce the types of problems we'll be doing these, I have a recipe for chili pepper souffle, which sounds very delicious to me. I think it would be good for dinner tonight. And I really want to make this recipe for chili pepper souffle. You know, it's Friday, can't have meat on Friday for my children, so I really want to make this recipe. The problem is I have everything in my cupboard and I don't have 2 cans or 1 large green chili salsa. I only have a half a can. So I still want to make it, and I think it'll be okay because there's only the 3 of us eating, so I don't think it'll be a really big deal. So how can I modify the recipe so that I can still make it and make it in the proper proportions if I only have a half of a can of green chili salsa? I do this all the time in cooking because I'm always out of something, or I only have, you know, a half a cup when I really need a cup, or whatever the case may be. Or maybe you want to make more. You know, maybe you're cooking for a large group and you want to double a recipe or triple a recipe. Well, really what it's all about are proportions, okay? So if, let's say, how much flour should I use if I only have a half a can of green chili salsa? What you're basically going to do is set up a proportion, okay? So here is our ratio that we need of flour to green chili salsa. For every 2 tablespoons of flour, you will need 2 cans of green chili salsa. The problem is in my cupboard, I only have 0.5 cans of green chili salsa. So how much flour should I use then? And really what this sets up to is a proportion. So you simply cross multiply, right? 2 times x is 2x. 2 times 1/2 is 1. And then divide both sides by 2 so you can get x by itself. So if I want to still make this recipe, instead of using 2 tablespoons of flour, I would use a half of a tablespoon of flour, okay? Now, again, chemistry's cooking anyway, and cooking's chemistry, so if you're a good chemist, you're a good cook, and vice versa. But how this relates to equations is that equations are really just like recipes. They give us the ratio of ingredients that we need and the ratio of products that will produce, except we read them not in cups and tablespoons and etc. We read them in moles. So what this equation right here, this zinc equation that you have in your notes is saying, if you mix 1 mole of zinc, okay, remember 1 mole is a formula mass, with 2 moles of hydrochloric acid, you will generate 1 mole of zinc chloride, which is dissolved in water, and 1 mole of hydrogen gas, okay? So the equation is like the recipe for how much of our ingredients we need, right? These are our ingredients. And how much of our products we will generate. So we are going to solve these stoichiometric calculations simply by using proportions, okay? Let's take a look at one. So example number 1, these are called mole-mole problems, and you'll see why in a minute. Gives you a reaction, okay, which means it's stoichiometry because we need the reaction to solve it. How many moles of water will be produced from the complete combustion of 3 moles of ethane? So we are given 3 moles of ethane, which, by the way, ethane has the formula C2H6. You probably could have figured that out because you know this thing's called oxygen and this thing's called carbon dioxide. And this thing's called water. So probably the thing that you didn't know the name of would be the thing that we're looking for, right? That's your ethane. So given 3 moles of ethane, how many moles of water will be produced? So they're asking us for moles of water. So you hopefully can see why we call this a mole-mole problem. You're given moles of one substance and they are asking you for moles of another. So we need the equation to figure out what ratio they should exist in. Just like I went to the recipe and found the ratio of my green chili salsa and my flour, right? I went to the recipe. We need to go to the recipe. And we need to find who we care about in our recipe or in our equation. Since they are giving us information about ethane, we care about it. We're going to underline it. They're giving us information about water. We care about it. We're going to underline water. Okay? Now we're going to put the given information under who it's given about. We're given 3 moles of ethane. So we're going to stick the 3 under the ethane, and they're asking us for moles of water, so we'll put the X under our water. And now we have a proportion set up to solve. For the equation says for every 2 moles of ethane, you will generate 6 moles of water. But the problem says, hey, I want to react 3 moles of ethane. So how much water will I generate? And you simply cross multiply 2x equals 18 and solve for x. X equals 9. And that's 9 moles of water. Okay? Really simple problems. All right, we'll do another example. How many moles of H2SO4 are required to react with 15 moles of NaOH? So we find the things that they're giving us and asking us about in the equation. They're giving us 15 moles of NaOH. So I go to the equation and I find NaOH and I underline it, okay? They're giving us 15 moles of it, so I put the given information underneath it. They're asking us how many moles of H2SO4, right? So they're asking us about H2SO4. They're asking us, so I put the X underneath it. Remember, if there is no number in the equation, it's a 1. So we have our proportion set up now. According to the equation, for every 1 mole of H2SO4, I will need 2 moles of NaOH. But the question says, hey, you want to react 15 moles of NaOH. So how much H2SO4 is that, right? 1 over X equals 2 over 15. Then you cross multiply 2x equals 15 and solve for x. X would be 7.5 moles of H2SO4. So we're not using any of those mole relationships that we learned in our notes because these are mole-mole problems. This is stoichiometry. We're using the equation. Okay? These coefficients represent the mole ratios that things must always react in or be produced in. Okay? All right, so I think we have a couple here in the Your Turn section of your notes. I believe there's 2. I'd like you to do those for Monday. Don't forget, Monday is also the final due date for your Penny Lab, so you should be taking a look at that. And I had asked you to do that worksheet number 1, that mole worksheet number 1 in your notes. If you did not finish it in class, you should have it done for Monday. So hopefully you get out, you get your chemistry done, you get to enjoy the weekend a little bit, everybody, and we'll see you on Monday. Bye-bye.